Hello dear students, welcome to the foundation course for PU1 Science. My name is Arun Chidling. I am a lecturer in physics. So today my topic to be discussed with you will be on calculus. So what is actually calculus? Calculus is a simple and advanced tool involving algebra and geometry. It is useful to solve the sophisticated problems of physics. Now, how do we figure out how will I apply calculus in physics? For that, I'll be displaying an image for you by which you might get a hint regarding the concept. Here we are having two images. In these two images, you can see the first one is about a problem in which regular maths can be used to solve it. Here a person is trying to push a crate over an inclination. In this case, the inclination is uniform and the force that is being applied by the man would be constant. But in other case, it is not constant. Let us find out what exactly happens in both the cases. So the first case, this problem is a regular math problem. Since the inclination is constant, then there will be no need of varying the force to push the object to a higher height. Since if you apply constant force with the same speed, the object is going to climb the inclination. And this can be solved by simple arithmetics and algebra, and finally we can solve the problem in physics. What about the other one, or why do we use calculus? In this scene you can see that the inclination is not constant. If it is not constant, then what happens? You need to use calculus. Now let me show why. If the inclination is changing, then at every point you need to apply the force, and the force has to change according to the inclination, that is steepness of the inclination. Since if you go on changing the force, then force is not going to remain same, and further you cannot use your simple algebra to get the result in physics. If a quantity is continuously varying, you cannot multiply it with some other quantity to get the final result. So then comes the need of calculus. So calculus basically has two branches in it, two major branches I can call. The first one is differentiation and the second is integration. So let us proceed with differentiation for today. Right. Now to understand differentiation or to apply differentiation, we need a concept as function, because differentiation is done on a function itself. So we shall understand what is function. Function is basically one quantity depending on another quantity. Here I mean to say that y is equal to f of x. What exactly this means? This means y is dependent variable and x is an independent variable. Now I mean to say that x can take independent values, whereas y will depend on the values of x that are chosen. So here you can see if I taken the value of x to be 1, then I get the value of y as 13. And if I take the value of x to be 2, then I get the value of y to be 23. What do I exactly mean here is y is dependent on the values of x, or in short I can say it as y is function of x. and we write it mathematically as y is equal to f of x. And such things are many in physics. One quantity in physics depends upon many other quantities. So that dependency itself is called as function, right? Moving ahead, let us try to take this dependency or function to be in the form of graph. Here in physics, we study the variation of one quantity with respect to another quantity. If I want to find out rate of change of y with respect to x, I mean to say how much y is going to change with small change or some change in x. We basically write it like y2 minus y1 divided by x2 minus x1. You can see that y2 minus y1 will be delta y. I can write it as change in y. This triangle is delta. I read it as delta y. So I have taken the difference. y2 minus y1, I'll get the length of it. Similarly, I can write it for x also. So I'll get a delta x. So I'll substitute their values further and get it to be like delta y by delta x. So if you see in simple, what does this rate of change of y means? It is nothing but delta y by delta x. Or graphically, I'll be trying to take a triangle here. So taking this triangle, I hope you can see that this is a right angle triangle and this is the angle. Then I can write where are the hypotenuse, adjacent and opposite for it. And here I am taking the ratio of, that is rate of change means ratio of, it will be opposite by adjacent. And you know which trigonometric function takes the values of opposite by adjacent. So it is tan theta. I can write tan theta is equal to opposite by adjacent, and here for us tan theta is giving the rate of change of y with respect to x. If you want to find out rate of change, then you need to take tan theta for the given 2 points. How much is the rate of change from this point to this point? You can find it this way. But this was for over a large period of curve, okay, on a large period of curve. What if I want to find the rate of change at this point itself? To do that, I'll try to make x2 come very close to x1. What do I mean by that is, I'll try to get this x2 very close to x1 by saying delta x is tending to 0. That means the difference between these two is very small. That means I'm trying to write it to be dx. When the difference between these two is very small, I'll try to write it like dx. If this is the case, then y2 also has to tend towards y1. A reason is, if x2 is tending to x1, then y2 should also tend to y1. So you can have a look at it here. I mean to say that delta y also should tend to 0. If it is tending, then I can write it to be dy. Now what I exactly mean by that is, I am trying to make this triangle to appear like a small dot. So I am trying to reduce the size of the triangle and finally it will become a dot. And I am interested to find the rate of change at this point. So I write it like dy by dx. That means I already told you, if these two are tending, then this becomes delta x becomes dx, delta y becomes dy. So I will put them here, and this is a rate of change of y with respect to x at one point itself. Or to make it understand easily with the graph, you need to do is draw a tangent to the curve at the point here. You can draw a tangent and take the slope of it. Find the slope of that, then you will get the rate of change at that point itself. Moving ahead, dy by dx is given with many different names. So all of them you might be using it or reading it. If you read them, all the three means same. As I have come across, differentiation of y with respect to x also means this itself. If you say slope of tangent on a curve y and x at a given point, then it means dy by dx. And also you can say it in physics, a rate of change of y with respect to x. We extensively use this in many of our concepts, which I'm going to say it at the end. So some of the theorems on differentiation, that is basic formulas, you can say. Well, now I'm trying to take is y is equal to c. Here c is constant. If I'm trying to draw a graph of y equals to c, c is a constant. What happens if I try to draw a graph of y equals to c? Since y is constant, you will get a straight line. So this is the value of y, it is c, and if x changes, then there is no change in y. Reason is y is not depending on x at all. It is just a constant number. So if I try to differentiate this, what will happen? If you try to differentiate that, then you will get 0. Reason is, even if x changes, if there is a change in x, then y does not change. So that's why dy by dx is 0 for y is equal to c. C is a constant. Constant means it can be any number, 1, 2, 3, 4, and any number. If it is so, then it is 0. Graphically it means y is constant, right? Similarly, along with this, now I'll try to take a standard formula of differentiation, which goes like y is equal to x to the power n. If you differentiate y with respect to x, the formula says that dy by dx should be equal to n x raised to n minus 1. So here it was x raised to n. I have got the n value here multiplied to x to the power n minus 1. Moving ahead, let us try to take an example for it. The example would be like trying to take y is equal to x to the power 3. Now I have to find out what's the rate of change of y with respect to x. To find that, I'll use this formula here, and here as x to the power 3 is there, and in the standard formula x to the power n should be equated with 3. That means n is equal to 3, and then differentiation will be, in the place of n I'll put the value of 3 and get the answer for this. This will be dy by dx is equal to 3 into x to the power 3 minus 1. So the final answer would be dy by dx is equal to 3x square. So this is a rate of change of y with respect to x for this function. So now let us try to take some of the standard formulas of differentiation. For this, I don't have any option. Unfortunately, you need to know these formulas. Later you are going to study them in mathematics, but presently you need to know the language of physics. So this is the basic language what I am trying to teach you. So for the function y is equal to sin x, differentiation will give you cos x. And for the function y is equal to cos x, differentiation will give you minus sin x. If you differentiate y is equal to cos x, you will get minus sin x. And for y is equal to log x, which you have studied, logarithm you have studied. So y is equal to log x, if there is a function like this, if you differentiate that, you will get 1 by x. And further, if there is y is equal to tan x, you differentiate it, you get sec square x. And if y is equal to cot x, differentiation of that will give you minus cosec square x. Last but not the least, y is equal to e to the power x, exponential functions. So e to the power x, then you will get e to the power x itself. So this one remains same even after differentiation. These were some of the standard formulas which you should note if you want to understand the basics of physics. Further, moving ahead, let us try to understand why are we studying differentiation in physics. So velocity and acceleration are two concepts of physics which actually are a rate of change with respect to time. So velocity is a rate of displacement with respect to time, and acceleration is a rate of change of velocity with respect to time. Next is power is the rate at which energy is consumed, and differentiation is used extensively in studying instantaneous rate of change of quantities. That exactly means is, if you assume that you are trying to ride a vehicle, the speedometer of the vehicle shows you the speed of the vehicle, right? Now what is exactly speed? Speed is rate of change of distance, okay, with respect to time. That means it is finding in how much time, how much distance is covered, right? So if you are trying to find in how much time, how much distance is covered, then distance has to be covered. Then how can the speedometer give you the exact speed value at that point itself? So it is giving you the speed exactly at that point just by the concept of calculus. So let us try to solve one of the problem on physics by using differentiation. So here there is a problem in which x and t is given. Here x is distance covered and t is time. So the relationship between these two is given. The relationship means this is function. X is function of t. Distance is covered with respect to time. So x equal to 3t plus 2. I need to find out what is the velocity. To understand that, let us understand the definition of velocity. Velocity is rate of change of displacement with respect to time. So I can write it like v is equal to dx by dt. Just substitute the value of x in the equation to get d by dt of 3t plus 2. To differentiate that, I'll try to split the equation and write differentiation separately for the two parts. Further, this formula will help us to differentiate. So differentiation of constant is 0. I mean to say d by dt of 2 will give me 0. So this is 0. Constant term does not change with time. Then the differentiation of this term will be found out using the standard formula. So here 3 is constant. I'm trying to keep it away from the differentiation, and I'll try to differentiate this term d by dt of t. To do that, I'll try to use the standard formula, that is d by dx of x raised to n, which is equal to n into x raised to n minus 1. I'll use it here. To use it, let us first of all figure out what's the value of n. So in the present case, value of n is 1. If the value of n is 1, then I can write it like 3 into 1. In place of n, I have put 1 t raised to 1 minus 1. In place of n, we have put 1. So this gives out to me t to the power 0, and t to the power 0 is 1. So finally, I get the value to be v is equal to 3 units. So this is the way we use differentiation in our physics. And thank you for the attentiveness, and have a good day.